Hi, this is Dave Cherry, the Coder's Corner. Today we're going to discuss TcMenu Designer version 4. We're going to show how to install it, how to start Designer up, create your own project, build the code, and lastly we'll go through the CLI for advanced users that want to use the command line support. To install TcMenu, simply go to the GitHub page and download the latest release for your operating system. We are now at the main TcMenu webpage. You can see here that the releases are available directly from that page, and you would normally select the appropriate build for your platform. Both Embed Control and TcMenu Designer are separately installable for your platform. Once you've installed TcMenu Designer, you'll see a screen similar to the following. Dependent which theme you've picked, it will either look like this or it will look like this. May look very slightly different on each operating system. So the first thing we need to do is go to the general settings, and within the general settings the Arduino projects folder and the libraries folder need to be set. So the projects folder is where you'll generally be saving your projects to, and the libraries folder will generally be where the libraries are installed if you have global libraries. If you don't have global libraries and you're using Platform I/O, you can untick this particular box here, the I am using Arduino IDE. But even for people using Platform I/O, I initially suggest that you have at least one global copy of libraries, because it helps you with the examples. If we look at the other options available on here, if you tick the use fully qualified variable names, it means that every menu variable will include all the submenus before it. So let's say if we look here at root menu item and then we have settings here, so it would mean that the action item here would be called settings action. So some people like that, some people don't. And the next option here, output CPP and headers into the source directory for new projects. What that does is it's saying that by default you want to create a source directory and put your source code into there instead of having it directly in the project folder. That's up to you how you normally organize your source code. And the last one that's ticked allows you to choose between EEPROM values being saved, sized or not. You can read about that in the documentation. The other two options here are number of backups and search depth. So number of backups sets how many backups will be kept in a .backup directory within your current folder. So this is how many copies of the EMF file it will store every time it saves it, basically, along with a few other files that get when they're changed. So it allows you a quick way to get back if something goes wrong. The sketch search depth sets how far below the sketch directory and below the examples directory it will look for recursively for EMF files, basically, that it can load up. The other more advanced options we'll cover later, and this second tab here, library versions, shows you the available and actual versions of everything that's installed. So I've already created a new project on the disk. I did that from the file menu by selecting create new project, and you can pick between either creating the project without saving it to disk first, or you can just fill in just a project name and choose the board type and generate the project from a shell, basically. So you end up with a shell project straight away. Right, so now what we're going to do is create the project as we had it laid out which means the first thing we need is a integer item, and this one was called room temperature. We wanted it to save to EEPROM, and let's say we wanted to know when that was changed, we could just say on room temp change, or just on room temp. We can also press the edit button, and this will allow us to choose whether we don't want to call back at all, if we want it with an implementation, or if we want to define it only. So what that means is it will not put any function definition in the main class, and you will have to declare it somewhere yourself. Normally, to start with, just create it using the standard way, which is just declared like that, just as a function name. And let's say we want to go from 0 to 128, so we can see there isn't a pre-made starter for that. So we know we start at 0. The maximum value is going to be 255 because it goes in steps of 2, and the divisor is 2. Now, at this point, let's bring up the preview window, because the preview window lets us see what this menu will look like as it's generated. So we'll move this over here, so we can see now that we've got our room temperature menu here. The unit won't be that, the unit will be Celsius. So we can see now that that's correctly, and let's try all the possible values, so we can see that this goes from 0 to 255 to 128 in steps of half. We don't want it to be read only, it's editable, and we want the item visible. So now we can go ahead and we can create the next item. So the next item will be an enum item. So this allows us to have choices that are hardwired up front, basically. They're going to be stored in the flash, so they can't be changed. If you need an enum that changes at runtime, or it has more complexity, you can use a scroll choice item. It gives you a much wider range of options. But for now, we just need 3 values, and it's called room conditioning. So we'll just set that up. Again, we want to save that to EEPROM, and it has 3 possible values. The first one is off. The next one is heating, and we'll add one more, and the last one is aircon. Yep, there we go. So to save on this screen, it's a little bit counterintuitive, but you just have to press enter once you've finished editing for it to save. And we can see there, we can try changing our default value, and you'll see the simulator update. So we'll start at 0 basically as the default. Again, standard settings there, nothing to be changed in the tick boxes. And now we're going to do vent temperature. So we'll do another add. This again will be another analog item. So we'll just do integer item create, and we'll call it vent temperature. This one won't be stored in EEPROM this time. We'll have one that isn't, and we won't store changes in it. And again, we want to go from the same range as last time, when the only thing we need to change is the divisor and the unit to be Celsius. Yep, there we go. So now we've got that. So the next thing we need to create is a submenu. This allows us to have another menu with items in it, away from the main menu. So we create our submenu, and we call this power. And then within the submenu power, we create another integer item. We'll create that, and this is called line voltage. It's not going to be stored, and in fact this one will be read-only, and it will go to 0 to 255, no step, nothing else, and the measure is voltage. And then our next one we want to create is current draw, and again this is going to be analog, so we'll create this and it will be called current draw. It won't be stored it will be read-only, and this will go from 1 to 10 in steps of 100, in steps of 10 tenths. So that is this, but this is actually wrong because we only want to go up to 10 amps. This would, if we look at this, this would let us go to 100 amps at full scale. So what we want is, we just want to go from 1 to 10, so we just need the divisor to be 10 and the maximum unit to be that, and we'll set it to 0 initially. And then lastly, we want to create a floating point item. Floating point items are useful for the output of calculations. So we'll create the floating point item and we'll call it power use. It doesn't have a callback and it just is to 1 decimal place. So we change that, and we don't need to make floating points read-only, they're not editable. They're not an accurate representation of a number. They're not suitable to use for editing, basically. Now at this point we've finished creating the menu, and in a few moments we'll go on to generate the code. So at this point we're going to generate the code for a Raspberry Pi Pico, which we just use the standard 32-bit ARM configuration for. We've got no other settings to change here, as we're not going to configure an EEPROM for it at the moment, and we're going to use polling for both keys and encoders, which is a little bit inefficient because it's going to constantly poll for the encoder, but it's the easiest thing to start with. So what we want to set first is the A pin. So from our previous page we know that the A pin was 16 and the B pin was 17 and the OK pin was on 21. We didn't have a left or a right button, and we're not using a quarter cycle encoder. We do want to use pull-up logic. That is pretty much the standard, which is you can use input pull-up from Arduino or the equivalent on embed, and then you in most cases wouldn't need any pull-up resistors, basically. So we want to change from the screen that we had chosen to the Adafruit Quick Start, and we want to change the display type to the ILI 9341, and that is pick the right display height and width. So what we want to do now is just configure the various pins. So reset, we said was on 19, chip select was on 20, and the register select was on 18. And let's start with display rotation of 1. We'll try that, and we'll maybe up the, we're going to use a reasonably fast library, so let's try and update the display updates per second to 10. And now this is an important setting, actually, the lines to buffer. So we have to set that to be big enough to handle 1 line of the menu. So let's set it to 40 for now. What that does is, every time a menu needs to be drawn, if it has enough space to double buffer it, it will draw it into an in-memory buffer, and the in-memory buffer uses a palette, which means that it uses far less memory than it would if it had to store the whole output that was going to the device. But then it can take that and it can push that data through much faster, basically, than it can do otherwise, because it doesn't have to keep doing different commands to the device. It can just send a line at a time. We'll come to that maybe later in another video, but just think that this is quite an important setting, especially on Adafruit, if you want high performance, basically. So we've picked a graphical display. We need to have a theme for it. So let's pick the modern cool blue theme. And we're not going to choose any remote capabilities. We'll have another video on that later. And now we've pressed the generate code button, we can see straight away that the process has finished. So we can, if need be, we can copy that to the clipboard if we wanted to look at it in more detail, or we could include debug lines which shows us extra things that it's done. So in this part of the video, we now switch to an IDE. In my case, I'm using Platform IO with Sea Lion IDE on the top of it. You could use the standard Arduino IDE. This is just a means to show you what the setup looks like. So let's take a look at the first file. So I've added several lines to the file. Now the first thing I've added is a standard line, and you'll see it in nearly every TcMenu example, and that is just a line that starts the serial port, and then underneath that I've actually set up the SPI for my particular Raspberry Pi, because I've got the SPI configured on these pins. You may, I mean, dependent on what you need, what display and other things that you've used, you may have to add some extra settings here yourself. If you've used any wire functions, you will need to do a wire begin before you call setup menu. Other than that, it's interesting to notice that the only thing in the loop is the Task Manager run loop, because TcMenu is based on Task Manager, and Task Manager does all the events on behalf of TcMenu. If we look at the file that's generated, the underscore menu.h, we can see that every menu that we've created is exported for our use in other parts of the program here. So we can access any of those in any part of the program. And we can see here that we can also access the display and other variables should we need to. The theme is also generated for us. Once it's generated, this file will not be touched again unless you delete it. So you can actually alter this theme to meet your requirements without the risk of it being overwritten. And then the plugins, you must not touch the plugins. It warns you at the top that you should not touch these files, because they're actually a plugin file and will be replaced. These files will be replaced. So now let's go back and have a look at the inno file again, and we can see that further down it has generated the room temperature callback that we set earlier. So let's say now that we wanted to change the menu room vent temperature, and we wanted to set its current value to 10, then whenever somebody clicks on the room temperature, it will set menu vent temperature to 10. What we can also do is we can schedule things to happen. So we can say schedule, and then we can do repeating in milliseconds. So we can say every, say, 250 milliseconds we want to run a task, and we can put the code we want to run in a lambda, which appears like this in the code. So we could say menu current draw dot set current value, and the current draw goes between 0 and 100. So what we could do, we could set that to a random, and we can mod that by 100. So that'll go between its minimum and maximum value. And then we could say menu line voltage, which is the other one that we have, and we could set that between 0 and 240 volts. And then lastly, we could do the floating point one, which was the power, which was the menu power use, which we can see there is a floating point menu item, and we can set its floating value And let's just use rand again, but this time we'll mod it by 1000, and then we'll turn this into a float and divide it by, let's say, 50. So now what we can see is that we've just added a few lines of code. So on a schedule, we'll alter some of the menu items in the status menu. Now that's what you normally do in a regular system. You know, you'd update your status values fairly frequently, and then in your callbacks, you would normally perform whatever activities needed to be performed. So now I'm going to start this to compile. We'll just reload the project first, and we'll run the debug task. Here you can see the application running. I've demonstrated the features that we added, and this concludes this part of the video. It's already 20 minutes long, so we're going to move the rest of the stuff to part 2. Thanks for watching, and please do subscribe.